Good day everyone, myself Dr. Vidyavathi, Assistant Professor in the Department of Chemistry, RNSIT, Bangalore. So today I am going to give the demonstration for one of the instrumentation, that is a conductometric estimation of acid mixture. See, in the estimation of the acid mixture by the conductometrically, we are going to use an analytical technology. So here what happens, here analytical technology helps us to determine what is exactly the amount of the substance which is there in the given sample by measuring the conductance. So by measuring the conductance, we are going to determine what is exactly the amount of the substance which is there in the given sample. In the instrumentation, there are three important steps. Okay? In the instrumentation, there are three important steps. The first step is to fill the burette with the titrant. So first step what we are going to do, we are going to fill the burette with the titrant. So in the conductometric estimation of acid mixture, we are going to fill the burette with the strong base, that is a sodium hydroxide. It is a titrant. Then the second step is the pipette of 25 ml of acid mixture. So pipette of 25 ml of acid mixture. So this acid mixture contains both the strong acid, that is an hydrochloric acid, and the weak acid, that is an acetic acid. It contains both the acids, strong acid as well as weak acid. Then we are going to add one test tube of demineralized water. So one test tube of demineralized water. So water we will add just to get the solution. So this is the second step. First step is the burette, second step pipette of given sample, that is an acid mixture, then one test tube of demineralized water. And the third step is the most important step. So since we are measuring the conductance, we are going to use a conductivity cell. So this conductivity cell is consisting of a glass vessel or a plastic vessel in which there will be two small platinum electrodes will be there like this. Okay, two small platinum electrodes will be there coated with the platinum black, and they will be separated about 1 centimeter apart. So if this type of conductivity cell we are using to measure the conductance, it is called as a specific conductance. Okay? So in this type there are two more types, that is a molar conductance and equivalent conductance. But according to the syllabus, we are going to use a specific conductance, so we are using this type of the conductivity cell. So this conductivity cell, what we are going to use, we are going to wash it thoroughly with the demineralized water, and it will be dipped in the solution whose conductance has to be measured, that is an sample. This conductivity cell will be connected to the conductometer, which will show the conductance values. So it will be connected to the conductometer, which will show the conductance values. So this is a setup. See, among the chemicals which we are using, either it may be the strong base or the strong acid or the weak acid, among the chemicals which we are using, so keep it in your mind that H plus and OH minus ions are high mobile ions. So if these ions are there, the conductance increases, because the higher the mobility of the ions, high will be the conductance. So if these ions are there, so the conductance increases. So after the setup, then we will be starting with the titration. So that is nothing but of an experiment. So during the titration or during the experiment, what we will do, we will add the titrant in the increment of 0.5 ml. So in the increments of 0.5 ml, that means what we mean by that is that nothing but of add 0.5 ml of NaOH. So we should wait for 2 to 3 minutes for the completion of the reaction. Then we should move down the reading. So continue the same thing. Okay. So then what happens after the setup? What we are going to do? We will start the titration. During the titration, so we will be adding the titrant in the increments of 0.5. So what happens before going to the titration or before starting an experiment, you should keep in your mind that since there are two types of an acid, that is a strong acid as well as a weak acid. So which acid will be neutralized? Because here is a neutralization reaction, that is an acid-base neutralization reaction, but there are two types of an acid. Which acid will be neutralized first? Anyway, in the PVC itself we will study that is according to the common air effect, first the strong acid will be neutralized. So what happens here, the first reaction takes place between the base, that is an NaOH, and the strong acid. Since we will be adding the NaOH in the increments of 0.5 ml, so first the strong acid, whatever the HCl will be there, it will be neutralized. So what happens during the neutralization reaction? So this H plus ions combines with the OH minus ions like this, and it will be removed as a water molecule. That is a neutralization reaction. Because of that, instead of HCl in the beaker, what happens? Then instead of HCl, there will be NaCl, since the H plus ions will be removed as water molecules. During the titration, what is happening in the beaker now? So since the HCl is neutralizing instead of HCl, so this H plus ions will be removed by the Na plus ions, so there will be a sodium chloride. So I have told you that H plus and OH minus ions are high mobile ions. So what is happening now? Since the high mobile, that is an H plus ion, is replacing by the Na plus is a less mobile ion, our conductance decreases. So initially the conductance decreases. When I give the demo for the experiment, I will show you how exactly the values decreases. So keep this in your mind. Initially the conductance decreases. Okay? It decreases because high mobile H plus will be replaced by less mobile Na plus. So this decreasing in the conductance goes on till the HCl is neutralized. After the completion of the neutralization of HCl, when there is no HCl in the beaker, so what happens? Now the neutralization of the acetic acid takes place. Now the reaction between the acetic acid, which is there in the beaker, and the titrant takes place. So what happens now? The next reaction will be the neutralization of acetic acid. So acetic acid will be neutralized. During the neutralization, same thing, what happens here? This OH minus ions combines with the H plus ions and it will be removed as a water molecule. In the beaker, there will be a formation of sodium acetate. So, sodium acetate will be formed. This sodium acetate is a good electrolyte. Because of that, there will be a slight increasing in the conductance. Not too sharp, slight increasing in the conductance. This is because of sodium acetate. Sodium acetate is a good electrolyte. So this slight increasing in the conductance continues till the neutralization of HCl, that is an acetic acid. After some point, even the HCl will also be neutralized. So then what happens? We will not stop the titration there only. So in the conductometric estimation, so keep the most important point in the mind, that is we should continue the titration till we get initial reading. For example, if our initial reading is 30, so we should continue till we get the initial reading, that is 30. So during that means we are going to continue the titration. Means what we are going to do, we will be adding the titrant in the increments of 0.5 ml. That means add 0.5 ml of NaOH, wait for 2 seconds, note down the reading. So what is happening during the continuing the titration? So we will be adding just the NaOH. So NaOH means there is a Na plus ions and OH minus ions. I have told you initially that the OH minus ions are high mobile ions. Because of this OH minus ions, after the neutralization of both acetic acid and the hydrochloric acid, there will be a sharp jump in the conductance. Okay, sharp jump because of OH minus ions. OH minus ions are the high mobile ions, so your conductance increases. So we should continue like this till we get the initial reading. Then stop the titration. Wash the apparatus and you should return it back everything, and you should come and say, do the calculation and plot the graph. You should plot the graph and do the calculation. So after completion, after completion of an experiment, what you should do? You should wash an apparatus, return it back, then you should come and say, plot the graph, then do the calculation. So when you do the calculation, you will be coming to know what is exactly the amount of the HCl and the acetic acid which is there in the given sample. So I have already told you that. So the aim of the experiment is to get the information regarding the concentration of the substance which is there in this given sample. So our sample contains the HCl and acetic acid. What is exactly the weight of the hydrochloric acid and the acetic acid which is there in the given sample? We will be measuring, we will be coming to know when we do the calculation. So this is the overall aim of the experiment. That means by measuring the conductance, we will be getting the information regarding the concentration of the substance. So this comes under the analytical technology. Now I will give the demo how exactly we are going to do the experiment. Then I will be teaching you how to do the calculation as well. The demo of an experiment for the conductometry is as follows. So the first step is we should fill the burette with the titrant, that is an sodium hydroxide for the conductometry. Then in the beaker we should pipette it out 25 ml of the acid mixture. As I have already told you that in the acid mixture contains both the strong acid, that is an hydrochloric acid, and the weak acid is an acetic acid. So what we should do? We should pipette it out 25 ml of the given acid mixture into the beaker. I have already done this. Then to this acid mixture, we should add 1 test tube of demineralized water. So 1 test tube of demineralized water. So water just to get the solution. So we are going to add 1 test tube of demineralized water. This is the second step. Okay. So the first step, we should pull the butane into the titrant, that is a sodium hydroxide. Then to the beaker, we should keep a heat of 25 ml of an acid mixture. Then 1 test tube of demineralized water. Since we are using here the magnetic field, so we have taken the magnetic bead. So the third step is washing the conductivity cell. So it will be like this, it's like just a bubble type like this. So I have told you that today we are going to use and measure the specific conductance. So this type of the conductivity cell we are going to use. So it is in a glass vessel in which there will be 2 small platinum electrodes will be there, coated by the platinum black, and they will be separated by around 1 centimeter apart. So what we should do, the first, before using the conductivity cell, we should wash thoroughly with the demineralized water. Wash the platinum electrodes as well. Then keep it aside. This is just a demineralized water. Then we should take the sample. Okay. Then we should dip it inside this conductivity cell into the. So you are maintaining the magnetic field. That is, you are using the magnetic field for the mixing of the solution. So switch it on. So magnetic field, it will help us to mix the sample. Then what we are going to do, we are going to start the titration. That is an experiment. So during the experiment, what we are going to do, we are going to add the titrant in the increments of 0.5 ml. So keep this in your mind, in the increments of 0.5 ml. So before starting an experiment, the most important thing is we should note down the initial reading. We should note down the initial reading. The initial reading is around 31.2. So this is very important. Why? Because we should continue the titration till we get an initial reading. So here the initial reading. So we have not added any of the titrant, that means we have not started any kind of reaction. So first initial reading we should note down. So the initial reading is 31.3. Note down that in the given manual. Then what we are going to do? We are going to start the titration. So as I have already told you that here since it contains both the strong acid as well as weak acid, so first the strong acid will be neutralized. So what we are going to do, you should add the titrant in the increments of 0.5 ml. So add 0.5 ml like this. Wait, okay. We should wait for 2 to 3 minutes. Okay, 2 to 3 minutes during the titration because it takes some time to completion of the reaction, that is a neutralization reaction. As I have already told you that, see when we add the titrant in increments of 0.5 ml, first the strong acid, that is an HCl, will be neutralized. So what happens during the neutralization of HCl, H plus ions will be replaced by less mobile Na plus ions. So there will be a formation of sodium chloride. So because of the decreasing in the H plus ions, there will be a decreasing in the conductance values also. So initially it was around 31.3. Now check it out, it is 29.6. Then again add 0.5 ml. Again add 0.5 ml. Then we should wait at least 2 to 3 seconds because it will take some time. So wait for 2 to 3 seconds or until you get a constant reading, then go down the reading. So this decreasing in the conductance continues till the neutralization of HCl. So 28.1. Okay. Then again add 0.5 ml. Again add 0.5 ml. Okay. Wait for 2 seconds. Then note down the reading. So we should give some time for the completion of the reaction. So add 0.5, then wait for 2 seconds. It's around 25.6. now there is an increasing in the conductance. So this tells that now the neutralization of HCl will be completed. Now the neutralization of acetic acid takes place. So I have told you that when the neutralization of acetic acid takes place, what will be there? So there will be formation of sodium acetate. So sodium acetate, since it is a good electrolyte, there will be a slight increase, not too sharp and all. See, from 10 it is like 10.5. It is an increasing in conductance. This is because of sodium electrolyte, that is a sodium acetate. It is a good electrolyte. So increases again at 0.5 ml. Wait for 2 seconds. And we should note down, see, slight increase, not too short, 10.7. Again add 0.5 ml. Wait for 2 seconds, note down the reading. So same procedure. So it's around 11.0. Again add 0.5 ml. Wait for 2 seconds. .8, again add 0.5 ml of the NaOH. It's 13.2. Sharp increase, right? From 13.2 it is increasing. So if there is a sharp increasing like this, so it tells us that so the acetic acid has also been neutralized. From 13.2 it is around 15.7. So this is called as a sharp increase. So our initial reading was 31, around 31 or 30 is enough. So we got an initial reading, so 31.3. Then we should stop, switch it off the magnetic field, then switch it off the instrument, then wash the apparatus, return it back, come and plot the graph. Okay, then do the calculation. When we do the calculation, we will get the information regarding it is exactly the weight of the HCl and then acetic acid which is at a given sample. Then after completion of the experiment, we should plot the graph. See, for the plotting the graph, for example, if we get like 31.3, 29.6, we should round off the values. See, if it is lesser than 0.5, go for the lower value, more than 0.5, go for the higher value. The values which I got during the instrumentation, that is as follows. So initial reading was around 31.3. So for the 0.5, it was around 29.6, 1, 28.1, 1.5, 25.6, 2, 23.1, 2.5, 20.8, 3, 19.3, 3.5 ml, 17.2, 4 ml, 15.3, 4.5 ml, 12.9, 5 ml, 11.3, 5.5 ml 10.1, 6 ml 10, 6.5 ml 10.5, 7 ml 10.7, 7.5 ml 11, 8 11.4, 8.5 ml 11.8, 9 ml 12.2, 9.5 ml 12.5, 10 ml 12.8, 10.5 ml 13.2, 11 ml 15.7, 11.5 ml 16.6, 12 ml 18.5, 12.5 ml 19.5, 13 ml 21.1, 13.5 ml 23.5, 14 ml 24.7, 14.5 ml 26.9, 15 ml 27.5, 15.5 ml 28.8, 16 ml 29.6 and 16.5 ml 31.3. So with the help of the graph, we are going to get the point of intersection, that is on how much exactly the volume of the NaOH which is required to neutralize an HCl, that is V1, we should substitute that, and the volume of the NaOH which is required to neutralize an HCl and an acetic acid, that is V2, we are going to get with the help of the graph. Okay, for the calculation part, so they will only give the what is an exactly the strength of the NaOH, that is a normality of the NaOH which we are going to take in the burette, that is 1 normal, and the volume of the acid mixture, that is in a tight trend, that is we have pipette it out 25 ml, so capital V will be equal to 25 ml. And the V1, that is the volume of the NaOH required to neutralize a HCl. So when we plot a graph, I got it as around 5.5, and the volume of the NaOH which is required to neutralize both HCl and acetic acid, when I plotted the graph, I got like around 10.5. Therefore, that is V2. So that means the volume of the NaOH which is required to neutralize acetic acid will be equal to V2 minus V1. So V2 minus V1, that is 10.5 minus 5.5, I got around, that is 5 ml. So now we should calculate exactly what is the weight of the HCl and acetic acid. I have told you now. So with the help of conductometer, we are going to get what is exactly the concentration of the solution that we are going to do now. For that, first we should calculate the normality of HCl. For that, what we are going to do, that is a normality of NaOH into V1, that is the volume of the NaOH required to neutralize an HCl divided by the V, capital V, that is the volume of the sample, that is 25 ml we have taken. So it will be equal to 1 into 5.5 divided by 25, we will be getting around 0.22 normal, that is the normality of HCl. Then since we want to calculate the weight of the HCl, so weight of the HCl will be equal to normality of HCl and then equivalent weight of HCl. So the normality, how much we got, like around 0.22 normal into 36.5 gram per dm cube. So this will be equal to 8.03 gram per dm cube. So this is the weight of the HCl which was present in a given sample. So same procedure for the acetic acid. So normality of acetic acid will be equal to the normality of NaOH, that is 1 normal, into V2 minus V1, that is 5, divided by the capital V, that is 25 ml of the acid mixture. So 1 into 5 divided by 25 will be equal to 0.2 normal. So to calculate the weight of the acetic acid which is present in the given sample, normality of acetic acid into the equivalent weight of acetic acid, that is normality of acetic acid we got as a 0.2 normal into the equivalent weight of the acetic acid is 60. So 0.2 into 60, we will be getting 12 gram per dm cube. So this is a calculation part. So by measuring the conductance, we will at last we will be getting the information regarding what is the strength, that is the weight of the HCl and the weight of the acetic acid which was there in the given sample. Thank you.